Welcome back, everybody, for another deep dive. This time, we're going to be tackling something pretty complex and fascinating all at the same time. It's called the free energy principle.
Yeah.
And it was really the brainchild of neuroscientist Karl Friston.
Yeah, that's right.
And it's really an attempt to explain how anything that's alive survives and interacts with the world.
Right.
So,
From a single-celled organism to the human brain.
exactly, yeah.
All kind of operating under the same principle.
And what I think is so fascinating about it is that it pulls in ideas from so many different fields.
Absolutely. It really does.
Like physics and statistics.
Even philosophy.
Yeah, so.
And so Friston argues that at their very core, all living things are driven by this one imperative to minimize free energy.
Okay, wait. Free energy. Now, we're not talking about the kind of energy that powers my house.
Quite no. It's a little bit more abstract than that.
Okay.
In this context, free energy refers to the difference between our predictions about the world and the actual sensory data we receive.
So it's like a measure of surprise.
Exactly. The more surprised we are by something, the more free energy our brain is experiencing.
That makes sense.
Think of it like this. Your brain is constantly building a model of the world, kind of like a scientist trying to understand the laws of the universe. A good model makes predictions with very few errors.
Right.
But a bad model is full of surprises because it doesn't match reality.
So according to the free energy principle, our brains are working really hard all the time to improve these models to avoid those surprises.
Exactly.
And how do they do that?
Through prediction.
Prediction. So is my brain like a little fortune teller or something like that?
In a way, yes. Your brain is making predictions about what you will see, hear, feel next.
Based on
its internal model. And it's happening incredibly fast, often, without you realizing it.
So give me an example.
Sure, think about catching a ball.
Yeah.
You don't consciously calculate the trajectory of the ball.
No, just
Your brain predicts where it's going to be and moves your hand accordingly. That's incredible.
all in a split second.
Okay, so that is really amazing. But if our brains are constantly predicting everything, how do we ever learn new things?
That's a great question. And it gets to the heart of how the free energy principle explains learning.
Okay.
When our predictions are wrong, when we experience these surprises or free energy, it actually triggers a process of updating our internal model to be more accurate. That's the basis of learning and adaptation.
So making mistakes is crucial
Absolutely.
for us to learn.
It means that our brains are constantly striving to be better, more efficient at predicting the world. And this ties in with another fascinating idea called the efficient coding hypothesis.
The efficient coding hypothesis. Okay, now we're going really deep here.
We are.
What is that?
Well, the efficient coding hypothesis suggests that our brains have evolved to represent information in the most compact and useful way possible.
So like compressing a file on your computer.
Exactly. You want to store the information in a way that takes up the least amount of space.
While still preserving the essential details.
So my brain is essentially a master of data compression.
That's a great way to put it.
Wow.
Think about how you can instantly recognize a friend's face, even in a crowded room.
Yeah.
Your brain isn't storing every single detail of their features. It's extracted the essential information and compressed it into an efficient neural code that's efficient coding at work.
That is so cool. So if I'm following this correctly, the free energy principle is all about minimizing surprise,
Yes.
maximizing efficiency.
Right.
And it's not just about our perceptions and our actions.
Oh, it's not.
This drive could even extend to our beliefs and values.
It's not quite that simple, but some philosophers have argued that our beliefs might be shaped by this desire for predictability, even if those beliefs aren't entirely accurate.
Okay.
It's a fascinating and somewhat unsettling idea.
Definitely unsettling. But before we go down that rabbit hole,
Sure.
I want to come back to this whole action aspect.
Oh.
If our brains are so focused on predicting the world, does that mean we're just passive observers, just reacting to whatever comes our way?
Not at all, and that's where the concept of active inference comes in.
Active inference.
Uh-huh.
Yeah, I'm going to need you to unpack that one for me.
So active inference takes the free energy principle a step further
Okay.
and says that living things aren't just passively predicting the world, they are actively shaping it to fit their predictions.
So we're not just fortune tellers.
Right.
We're world builders.
Precisely. Instead of just predicting we will feel warmer, we put on a coat to make that prediction come true. It's about influencing our environment to reduce uncertainty and make the world a more predictable place.
Okay, that is mind-blowing.
It is.
See, if our brains are so good at this prediction game,
Yeah.
does that mean that we're basically living in a self-created simulation?
That's a thought-provoking question.
It is.
And it leads us to some of the deeper philosophical implications of the free energy principle.
Yeah.
It makes you wonder about the nature of reality itself.
Absolutely.
Yeah.
But I think we need to pause here for a moment.
Okay.
I think we've covered a lot of ground already.
Yeah, a
And
lot to digest.
I want to make sure our listeners are still with us.
Absolutely.
Hopefully, we've laid a good foundation for understanding Karl Friston's free energy principle.
I think we have.
But there's still so much more to explore. So join us for part 2 of our deep dive as we continue to unpack the free energy principle. And we'll get into things like the implications for AI and maybe even touch on some of those philosophical questions that we've been teasing.
Sounds good.
All right, see you there.
See you there. Welcome back to our deep dive into Karl Friston's free energy principle.
I'm still processing everything we talked about last time.
It is a lot to take in.
It's like a complete system upgrade for my brain.
It really is a powerful framework, and it has implications that go far beyond just understanding how brains work.
So where do we go from here?
Well, remember how we talked about active inference?
Yeah, the whole idea that we're not just predicting the world.
Right.
We're actually shaping it.
To match our predictions.
Yeah.
And this principle might apply to more than just brains.
Okay.
It could potentially explain intelligent behavior in all sorts of systems.
Yeah.
From single cells to entire ecosystems.
Wait, so you're telling me that something as simple as a single cell can engage in active inference?
Let's think about a simple organism like a bacterium.
Okay.
It has a very basic model of its environment. Find food, avoid danger. It doesn't have a complex brain like ours, but it can still sense its surroundings and act in ways that help it survive.
So the bacterium is making predictions about where it will find food and then moving toward it.
Exactly.
And if it encounters danger, it changes course.
It's a very simple form of active inference,
Right.
but it illustrates the basic principle: living things act on their environment to make their predictions come true.
And this idea scales up to more complex systems.
Yes. Think about a plant growing towards sunlight. It's not consciously thinking I need to get more light,
Right.
but it's still acting in a way that maximizes its chances of survival.
So there's this underlying drive towards minimizing surprise and uncertainty.
That runs through all of nature.
Wow.
And that brings us back to the free energy principle. It provides a mathematical framework for understanding this drive in a very rigorous way.
I'm getting a little lost in the math here.
Sure.
Can we bring this back down to earth with some real-world examples?
Of course. Remember the thermostat example we talked about earlier?
Yeah, you said it's like the thermostat has a simple model of the room's temperature
Right.
and acts to minimize the free energy, which is the difference between the desired temperature
Right.
and the actual temperature.
Now imagine a more sophisticated thermostat that can learn your preferences and adjust the temperature based on your past behavior.
Right.
Let's say you usually turn the heat down at night.
Mm-hmm.
This smart thermostat could start to predict that you'll want the room cooler in the evening and adjust the temperature automatically without you even having to touch it.
So it's not just reacting to the current temperature.
Right.
It's anticipating my needs based on my past behavior.
Exactly. It's a form of active inference because the thermostat is actively shaping the environment to match its predictions about your preferences.
That's amazing.
And the more data it gathers about your behavior, the more accurate its predictions become, and the more seamlessly it can adjust the temperature to keep you comfortable.
So if we can build smart thermostats that use active inference,
Yes.
could we also build AI systems that are similarly intelligent and adaptive?
That's the hope. By designing AI systems based on the principles of the free energy principle and active inference, we might be able to create machines that are much more flexible, adaptable, and capable of learning from their mistakes.
That's exciting and a little scary.
It's true. There's enormous potential, but also significant risks. That's why it's so important to have these conversations now, to think carefully about the ethical implications of developing increasingly sophisticated AI. But getting back to the science.
Yes, please. I'm eager to hear more about how researchers are actually studying the free energy principle in the brain.
There are a number of promising avenues being explored. One technique is called the Perturbational Complexity Index, or PCI for short.
PCI.
It uses transcranial magnetic stimulation, or TMS, to briefly disrupt brain activity in a specific area.
So they're basically poking the brain with magnetic pulses.
In a very controlled and precise way, yes.
Okay.
And then they use EEG to measure the complexity of the brain's response to this perturbation. The idea is that a brain with high integrated information and therefore high consciousness will produce a more complex response to the TMS pulse.
So they're testing how resilient and adaptable the brain is to disruptions.
Exactly. And the results of these studies are helping to provide evidence for the free energy principle. They suggest that the brain is constantly striving to maintain a state of optimal balance, even when faced with unexpected challenges.
It sounds like our brains are these incredibly complex self-regulating systems that are working all the time to minimize surprise and uncertainty.
And the implications of this go far beyond just understanding how brains work. It could change how we think about everything, from mental health to education, to the very nature of consciousness itself.
I feel like we've gone from bacteria to brains to the potential for conscious AI,
We have.
all in the span of this one conversation.
It's been quite a journey.
But before we get too carried away, I want to circle back to something you mentioned earlier.
Okay.
You said the free energy principle could have implications for mental health.
Absolutely. Many mental health conditions, such as anxiety and depression, can be seen as disruptions in the brain's ability to effectively minimize free energy.
So if someone is experiencing anxiety,
Yes.
is it because their brain is generating too much free energy?
In a way, yes. For example, someone with social anxiety might have a hyperactive fear response that generates excessive free energy in social situations. Their brain is essentially predicting danger where there is none, leading to feelings of fear and avoidance.
So their brain is kind of overreacting.
In a way, yes. Their internal model is generating predictions that don't match reality.
So could understanding the free energy principle help us develop new treatments for mental health conditions?
That's the hope. Some researchers are exploring how therapies that focus on reducing uncertainty and promoting a sense of safety and control could help recalibrate the brain's free energy regulation.
So basically helping the brain to make more accurate predictions.
Exactly, and to better manage those surprises when they do occur.
That's fascinating. It's amazing to think that a theory as abstract as the free energy principle could have such tangible implications for our well-being.
It really is. It's a testament to the power of scientific inquiry and the importance of exploring new ideas, even if they seem strange or counterintuitive at first.
Okay, I think we've pushed our brains to the limit for now.
A lot to take in.
We've covered a lot of ground, from the basics of the free energy principle to its potential applications in AI and mental health.
And we're not done yet.
There's still more to explore. So join us for the final part of our deep dive as we delve into the philosophical implications of the free energy principle and consider what it might mean for our understanding of free will consciousness and the very nature of reality.
I'll see you there.
Welcome back to our deep dive into Karl Friston's free energy principle.
It's been quite a journey.
It really has. We've covered so much ground, from predicting the future to reshaping the world to fit our expectations.
Yeah, even how this principle might be at play in everything from bacteria to super intelligent AI.
It's incredible.
Huh.
But there's one thing that keeps nagging at me.
Okay, what's that?
If our brains are constantly trying to minimize surprise,
Yeah.
does that mean we're somehow limited in our ability to be truly creative or spontaneous?
That's a great question, and it really gets at one of the most fascinating paradoxes of the free energy principle. On the one hand, we seem to be wired for predictability.
Yeah.
But on the other hand, humans are incredibly creative beings, constantly coming up with new ideas and inventions art.
So how do we reconcile those two seemingly contradictory drives?
Well, one way to think about it is that novelty and exploration can actually be seen as forms of free energy minimization in disguise. Remember, free energy isn't just about avoiding surprises, it's about reducing uncertainty.
Right. So when we encounter something new, it creates uncertainty.
Exactly.
Because our brains don't have a good model for it yet.
Precisely. And that uncertainty motivates us to explore, to gather more information, and to update our internal models to include this new element.
So by seeking out new experiences, we're actually trying to reduce uncertainty in the long run.
Exactly.
It's like our brains are saying, hey, this new thing is weird and unpredictable. Let's figure it out so it's not so weird anymore.
That's a great way to put it. Curiosity and exploration aren't at odds with free energy minimization. They're actually crucial components of it.
It's how we expand our understanding of the world and make it a more predictable place. It makes a lot of sense. But I have to ask, where does free will fit into all of this? If our brains are constantly making predictions and acting to make those predictions come true, does that leave any room for conscious choice?
Ah, yes. The age-old quotient of free will.
Right.
It's a topic that philosophers have been debating for centuries, and the free energy principle just adds another layer of complexity to the discussion.
So is free will just an illusion? Are we just puppets dancing to the strings of our predictive brains?
I wouldn't say it's that simple. The free energy principle doesn't necessarily deny the existence of free will. It simply offers a different perspective on how it might work.
Okay, I'm intrigued. Give me the free energy principle take on free will.
Well, one way to think about it is that our choices aren't random.
Okay.
They're shaped by our internal models of the world, our past experiences, our goals and values. But those models are constantly being updated and refined based on new information and feedback from the environment.
So it's like our brains are generating a range of possible actions.
Right.
And then we consciously choose the one that seems most likely to minimize free energy.
Given our current understanding of the world,
Exactly.
it's a dynamic interplay between prediction, action, and feedback. We're not just passively reacting to the world, we're actively shaping it and being shaped by it.
That's pretty empowering. It suggests that we have more agency than we might realize.
Exactly. The free energy principle doesn't negate free will. It simply reframes it within this broader framework of biological and computational principles.
This has been such a mind-expanding conversation.
It has been a lot of fun.
We've covered so much from the basics of the free energy principle to its implications for everything, from AI to free will.
It's a testament to the breadth and depth of Karl Friston's work. He really is one of the most innovative and influential neuroscientists of our time.
He really is. As we wrap up this deep dive, what's the final takeaway for our listeners? What do you hope they'll walk away with?
I hope they'll come away with a new appreciation for the incredible complexity and adaptability of the human brain. The free energy principle offers a really powerful framework for understanding how we interact with the world, make decisions, and even experience consciousness itself.
Yeah, and maybe most importantly, it reminds us that we're not just passive observers.
Right.
We're active agents
Yes.
who have the power to shape our reality.
Well said.
And who knows what other mysteries this principle might help us unlock in the years to come.
The possibilities are endless.
Thank you so much for joining us on this deep dive into the fascinating world of the free energy principle.
It's been my pleasure.
It's been great having you. Until next time, keep those brains predicting and those minds expanding.